Hello, Mastery Algebra 1. This is Mr. White, and I'm going to be presenting Lesson 10-1, the Pythagorean Theorem. The Pythagorean Theorem was one of the first theorems used by mathematicians in ancient civilizations. What it's used for is we're going to take and find the lengths of the sides of a right triangle and understand that they have this special relationship. And if we know the lengths of any two sides of a right triangle, then the length of that third side can be found. And that's using this Pythagorean theorem. So there are special names of the sides of a right triangle, like the one that we're going to solve, or the side opposite the right angle. So here's our little box that gives us our 90-degree right angle. Okay, this side that's opposite, we're going to call that the hypotenuse. And each of the sides that help make this right angle, consider like this bottom base, which is A, and this B side, okay, those are going to be called the legs or sides. The Pythagorean theorem, named after the Greek mathematician Pythagoras, relates those lengths to the actual hypotenuse. So the note that we want to look at, in any right triangle, such that we have a triangle, that right triangle, we can say that the leg squared plus the other leg squared should be equal to the hypotenuse squared. Okay? Or in algebra, we're going to take and go a squared plus b squared equals c squared. So we're going to use the Pythagorean theorem to find the length of the right triangle hypotenuse given the lengths of its legs. Okay? Or if we give you a length of a leg and the hypotenuse, can we go backwards and find the length of the other leg? Problem number 1. The tiles at the right are squares with 6-inch sides. Okay, what is the length of the hypotenuse of the right triangle shown? So we have this C. We're going to use our formula a squared plus b squared equals c squared, where a and b are that length of the legs. Okay, we know both legs, since it is a square, are 6 inches. So if we input 6 into a and b, we're going to get 6 squared plus 6 squared. So then when we solve and combine both legs, we get 36 plus 36, which is 72. So 72 is the length of that hypotenuse squared. How do we undo a square? We have to square root both sides. And because we're dealing with some geometric figure, remember it was a plus and minus, but we don't need a negative side for distance. So we're just going to say that the c is approximately equal to the positive. Well, if you take the square root of 72, we're going to get 8.5 inches. So we can say that the length of the hypotenuse is about 8.5 inches. Next one. Well, what is the length of the hypotenuse in a right triangle with legs 9 and 12 centimeters? So if we draw our handy-dandy right triangle, so we here have the right angle, let's put the smaller side at the bottom. So we'll go, this is 9 centimeters, and we have 12, and we'll call this again. Using the formula, we have a squared plus b squared equals c squared. We're going to plug in 9 and 12 to both sides. So we have 9 squared plus 12 squared should be equal to c squared. 9 times 9 is 81. 12 times 12 is 144. And we get c squared. Okay. When we combine the left-hand side, hopefully you are getting 225, which is equal to that c squared. So again, how do we undo a square number? We have to square root both sides, only taking the positive because it is a distance. And we get c is equal to 15 centimeters. So we can say that the length of the hypotenuse is about 15 centimeters. Next page. You can also use Pythagorean theorem to find the length of a leg of a right triangle given the hypotenuse in one leg. Okay, so problem number 2 says on the right hand side we have a base B that we do not know. We have a height or a leg of 5 and a hypotenuse of 13. So if we use the formula, we know a squared plus b squared equals c squared. Okay, make sure we show our work. We're going to plug in our a squared. Our a squared could be that shortest side, so we'll just call that 5 squared. And since b is the variable we're using, we're going to keep the b squared, and then that is now equal to 13 squared. If we multiply these out, we're going to get 25 plus b squared equals 169. Now we have to solve for b squared. So we need to move this 25 over to the other side by subtraction. Okay? By doing that, we're going to get b squared is equal to 169 minus 25, which is 144. Okay? Now, if again we take the square root, b is going to equal 12 centimeters. So the length of the side b is 12 centimeters. All right, your turn. Go ahead, hit pause, do number 2. Check back in a couple minutes. Go. Welcome back. What you should have gotten is we are solving for that a side. So I kept the a squared, plugged in the 12 and the 15, and you should have gotten the length of the side a is 9. Good job. Let's scroll down. Okay, we're going to look at now the property, the converse of the Pythagorean theorem. Okay. If a triangle has sides a, b, and c, and a squared plus b squared is equal to c squared, then we know we have a right triangle. In other words, before we actually looked at if we have a right triangle, then a squared plus b squared is equal to c squared. Okay. So now we're using what's called the converse. So what we're going to do is, given these 3 sides, okay, one of them being the hypotenuse, we need to figure out, does it give us a right triangle? Is a squared plus b squared equals c squared? Now, if you actually look at in problem 3, a, b, c, and d, we need to make sure that, remember, the c squared is always the longest side, so we're going to plug in the biggest number, the largest number for our c. So if we look at a, we have 6, 24, and 25. Well, we know a squared plus b squared equals c squared. So we'll plug in just accordingly to here. So 6 squared plus 24 squared is equal to 25 squared. If that is true, we do have a right triangle. Using a calculator or multiplying those out, we're going to get 36, 576 should be equal to 625. 36 plus 576 is 612. Is that equal to 625? No. So this one's no, not a right triangle. Okay. B. If we take 4 squared plus 8 squared, that should be equal to 10 squared. 16 plus 64 should be equal to 100. So 16 plus 64 gives us 80. And we know 80 is not equal to 100. So again, no, these are not a right triangle. If we do the next one, we have 10, 24, and 26. 26 is the biggest number, so we're going to go 10 squared plus 24 squared should be equal to 26 squared. Is 100 plus 576 equal to 26 times 26, which is 676. Add those together, 676 is equal to 676. So a little check mark, yes, this is a right triangle. And the last one, we have 8, 15, and 16. So 8 squared plus 15 squared should be equal to 16 squared. 64 plus 225 should be equal to 256. Okay. 64 plus 225 is 289. That is not equal to 256. So the answer is no. So the only one that was a right triangle with sides was 10, 24, and 26. Letter C. Okay, again, go ahead, hit pause. Your turn to do number 3. We want to find out, could 20, 47, and 52 be the side lengths of a right triangle? And use your work to explain. Alright, welcome back. By plugging in, we got 20 squared is 400, 47 squared is 2209, and 52 squared, it was 2704. Put those together, and we do not get 2609 equal to 2704. So it is not a right triangle. Good job. Alright, you're going to hit pause in a second. You're going to do these next 2 pages. Okay? Look at the following lengths forming a right triangle and finding missing sides. Okay, make sure you round to the nearest tenth. Show all your work. Go ahead, hit pause. Go. Alright, welcome back. Again, here's checking your answers. Okay, make sure you have the appropriate work. There's 1 through 6, 7 through 12, and 13 through 16. Again, you are rounding your answers to the nearest tenth. And the last couple, 17 through 22. If you still have any questions, be sure to ask. Otherwise, we hope you have a great day, night, morning. And remember, always do your best, forget the rest. Bye for now.